Okay, so in this video we're going to analyze this nonlinear differential equation. Now notice that on the right hand side we have an expression of y which we'll call f of y. It's going to be helpful in this analysis to first factor this equation, and we can do so by writing it as y times 1 minus y squared, and we can even factor it a little bit more to create three factors: 1 plus y and 1 minus y. This quantity tells us something about the rate at which y changes. In this table we keep track of the value of y and the sign of f of y, which is the expression on the right hand side. Let's first look at a few values that are very easy to compute. F of y will be 0 when y is either minus 1, 0, or 1. So on these three values we can immediately write down that f of y is 0. The behavior, there's no change, and similarly here, no change, since f of y describes the rate of change of y. Now let's look and see what happens between these values. So for example, suppose we take the value of negative 0.5, plug that into this equation. This will be negative, this will be positive, this will be positive. So altogether, the sign will be negative. On the other hand, if we plug in a value of y which is less than negative 1, for example, you might want to plug in minus 2 to try this out, then we find a negative here, and a positive here. Two negatives, when multiplied, create a positive value, and so here we get a positive value for f of y. So this information tells us that y increases with time. Over here, the fact that this is negative, this tells us that y decreases. Now we can go on and complete this table, and so the direction of the tangent line, here it will be sloping upwards, here it will be flat, here it will slope downwards, here there'll be no change, up, no change, and downwards. Next, we assemble all this information in what we call a slope field diagram. We're going to graph y as a function of t, indicating the information in the table. For the values y equals 1, there's no change. Similarly, for the value y equals minus 1, there's no change. And the same thing goes for y equals 0. Now, what about 0.5? Let's look and see what we've got. Y increases, the slope of the tangent lines points up, like so. On the other hand, for y equals minus 0.5, y decreases, things slope downwards. And we draw that this way. Let's now consider what happens from different initial conditions. So let's pick a few initial conditions. For instance, let's take a few points on the t equals 0 axis, the y-axis, and follow along and see what happens. So the tangent line points upwards, which means we're going to be moving up, but then eventually we have to gradually move sideways because we cannot cross this dashed line. Similarly here we move upwards. Here the tangent lines all point downwards. Here again they point downwards, leading us toward this value, and here they point back up again. Using only information about the sign of this expression that sits on the right-hand side of the equation, we've been able to assemble a pretty good qualitative idea of the behavior of y as a function of time.